I want to talk a bit about the climate change, where we are and where we're going, and the scenarios and pathways into the future. So that's the purpose of my talk. And I'm basing a lot of it on the work that I've been doing with the IPCC, especially around the Land and Climate Report, which came out in the summer of 2019, just this past summer, and the current work on the sixth assessment cycle. So we'll look a little bit at climate change. And for many of you in this room, I know this isn't new, that you've probably seen these many, many times before, so I may skip over them. And then I'm going to talk a little bit around scenarios and pathways, some of the work that's been coming out of Working Group 1 of the IPCC and was foundational in the Land and Climate Report, so I'm basing it on that work. And then talk a little bit about pathways into the future, based partly on that report and then partly just on some work that is starting to go on in this campus and in this province. So this is the special report on land and climate change that came out. It was a special report. So talking a little bit about what is the IPCC, for anyone that maybe isn't so familiar with it. It generally uses the name IPCC because otherwise it's Intergovernmental Panel on Climate Change, which is so long. So that's what we mean when we're referring to IPCC. It's established by, you see those two organizations there, the World Meteorological Organization and the United Nations Environmental Program. So those are kind of the founding agencies. But the IPCC was really set up to advise the United Nations Framework Convention on Climate Change, that's the Kyoto Protocol, Paris Agreement body, about the science on climate change. So they've been in existence for several decades, and they have certain processes that they go through in a certain institutional structure, which is what you see on this slide. So there's a secretariat, a working group over here, an executive committee, and then an IPCC bureau is what they're called. And the plenary is actually made up of nation states of the United Nations. So that's what we mean by the IPCC plenary. The working groups of the IPCC are divided actually into 3 groups and a task force. And the first working group works on the physical science base, the second working group on impacts, adaptation, and vulnerability, the third on mitigation, and then there's a special task force on national greenhouse gas inventories. So the special report on land and climate was actually a product of all 4 of these groups. So they came together and developed a special report, and there were 3 special reports that were done in the last couple years. Land and climate was one. You may have heard of the other one that came before it, which we call the 1.5. It's the one about how do we meet the climate commitments of maintaining global warming well below 2 and approaching 1.5 degrees warming. And then there was a cryospheres report that came out in September. So those were the main special reports. And then when Sarah was introducing me, the AR6, it stands for the 6th assessment cycle. So every 6 years, the IPCC puts out a big report, and each working group works on a report. So there's 3 big reports that are coming out. They'll be out in a couple years. One is the physical. I'm working on the second, impacts, adaptation, and vulnerability, and a third working group meets and works on mitigation. And those will come out. They're always all online, but they're very large. And they're made up of authors, contributors, and reviewers that are working on them. And the process of the IPCC in making these reports are always the same. So there's always a scoping where the report is actually scoped out for what the table of contents is, what's going to be in it, what it's going to cover, what are the main topics. There's an actual approval backed by that plenary, which is all the nation states that are meeting about every couple times a year. So the actual outline will be approved by member states. And then a nomination of authors occurs, whereby the scientists are actually nominated by their peers, and then the nation states, so Canada, reviews all the nominations, put forward to the IPCC experts, And then the IPCC once again reviews those experts and picks out the nominations for a few that they extend an invitation to come and be an author or a review editor or a coordinating lead author in one of those special reports or those working group assessment cycles. So that's kind of the process. And then there's a whole bunch of drafts that occur, a final government distribution, and at the very end of the process, the whole entire report goes up into a plenary, and the summary for policymakers that comes out of that report is actually approved line by line by the governments in the plenary of the IPCC. So it's quite a process, and the summary for policymakers is a negotiation process. So it takes a couple years to get through that process. With the Land and Climate Report, there was a total of 107 authors that worked on that special report. 40% of the coordinating lead authors, these are the people that organize and write the report with the help of lead authors. 40% of them are female. There were 52 countries represented. 53% of the authors were from developing countries. And 7,000 scientific publications were assessed or referenced within that Land and Climate Report. And when we went through all of those drafts that I was showing you, the first, second, third, and the final, there was a total of 28,275 review comments by experts around the world on land and climate change. So that's kind of the process that goes into one of the IPCC reports. And we end up with a report that looks something like this. And it's all online. So no longer the huge big books, very accessible to the public, and a summary for policymakers that's written in what is hoped to be an accessible, easy to understand, non-technical language for people around the world to learn, understand, and take heart to. So that's just a bit about the IPCC process, how it happens, who writes it, and how it gets to the findings that I'm going to speak a little bit about where are we with the climate change, okay? So this was one of the main takeaway messages about land that came out in the Land and Climate Change Report is it's a critical resource. We rely on it for food, water, health, well-being, but it's under great human pressure, and climate change is adding to those pressures. So I'm going to speak just a little bit to climate change. And this is one of the figures that came out of the report that's been produced by many entities around the world. And what it's showing is the change in temperature from a reference point of 1850 to 1900 into 2018. And we're interested in that time frame because prior to 1850 is prior to industrialization. So this is the time period when we started to really burn fossil fuels in our development, and we're tracing the change in surface air temperature on the top of this figure, and then the change on the bottom is global mean surface temperature. So why this is important to bring it to your attention is to think of it in the context of the Paris commitments, which I mentioned at the beginning are our commitments to keep global warming below 2 degrees Celsius, trying to attempt to keep it at 1.5, the goal of the 1.5 report. So what you're taking from this is the fact that our temperature over land has actually increased, the global mean average, to almost 2 degrees Celsius already. So we're already exceeding that Paris commitment in respect of the land temperature. And in respect of the ocean, we're over 1. And this is as of August of 2019, last year. This is a figure that is based on the IPCC, but has been put together by the US Global Climate Change Research Program. And I do believe I saw Britt's presentation. She's covered some of the incredible challenge around the atmospheric gases and CO2 and what we're facing in the context of climate change. And this graph is just summarizing much of the information that she's already covered and showing you at the bottom the observations in respect of climate. And the science is getting very, very good at determining what are the natural and human factors that are contributing to climate change, and then the bottom, this blue line here, separating out what climate change would have looked like, or the climate measurements in relation to natural factors only. So we're starting to call this attribution, the attribution science. And there's a lot of attention that's been paid in the peer-reviewed publications to attribution. So what's natural, what's anthropogenic, or natural and human factors, and separating these out. And we'll see a lot more coming out of the AR6 in this regard. So we know it's warming, and it's warming quickly, and we're into a situation where we don't really know what's going on with a lot of the mixtures of those gases, but we do know this is the global temperature change, the deviation into 2018. And it shows the warming, the incredible warming happening in the northern latitudes, and the warming happening through Canada, and less so in other parts of the world. So this is all the climate change that we are seeing and experiencing now. We're not looking at future projections or pathways yet. So not only is our warming unprecedented, but it's also occurring at a time when human activity creates stresses that compound the effects of warming, so much so that scientists have coined the era to be the beginning of a new geological period called the Anthropocene, a time when human activity is the most dominant. So you'll see this word being used a lot. And there's no scientific consensus around this word or around this epoch, but you'll start hearing it a lot more. So I said I was going to talk a bit about what the IPCC is, and the special report, the 6th assessment, what the climate change is that we're seeing and we're experiencing, and then start talking a little bit around scenarios and pathways. So I'm in this area right here about scenarios and pathways and why are they important. So we've looked at what has happened with our climate in the past, and now we're looking at scenarios of what we expect to happen into the future. So they're an essential part of climate change research and assessment, and they're really important when it comes to decision making and risk assessment in the context of climate change and the increasing impacts that we're seeing of climate change relating to drought, relating to flood, relating to our less cold winters, and our increasing number of days of above 30 temperatures in the summer. So what's going to happen into the future is the question, and why is it important? So one of the reasons it's really important is because it's the foundational science that I mentioned that we use in our United Nations Framework Convention climate change negotiations for determining where we'll try and limit GHG emissions in order to keep global warming in check. But here what I'm showing you is a figure that's been produced by Positive Energy at the University of Ottawa, and it's actually looking at what our actual emissions are and what we said in Canada we would do, the certain commitments that we had made, starting with Rio in 1990 and Kyoto in 1997 and Copenhagen in 2009 and now Paris in 2016. So Dr. Monica Gattinger put this together, and I thought it was very, very good, showing a bit of one of what we're up against, some of the obstacles we're facing to addressing this climate change. So we know that we want to keep global emissions down, and we know that we have to reduce greenhouse gas emissions and commit to it. So what the first scenarios we need to think about when we're thinking about the science around climate change, the emission scenarios. So the emission scenarios are the emissions of greenhouse gas that I'm speaking about. So when we reduce greenhouse gas emissions, we reduce it to this GHG. Okay, so when I say GHG, I'm referring to greenhouse gases, which are a combination of CO2, carbon dioxide, methane, all of these gases that contribute to global warming, okay? So what happened with emissions and talking about emissions scenario is there was papers and agreements amongst the climate change scientists that they would determine these radiative forcing values about how much greenhouse gases were in the atmosphere, and they would produce models or climate change scenarios based on these emission scenarios. So how much greenhouse gases, whether it's 490 parts per million CO2 equivalent of greenhouse gases, which is the lowest of the radiative forcing values, this concentrated pathways, versus RCP, which is 8.5, which is 1,370 parts per million. So the scientists came up with 4 of these representative concentration pathways representing future greenhouse gas emissions. And they started to build out their climate change scenarios looking at these possible futures. So if we get a handle on our greenhouse gases and we can keep it low at 490 parts per million, then here we are with a certain pathway that is looking at a lower climate warming around 2 degrees Celsius. But if we keep increasing our greenhouse gas emissions to 1,370, so the highest representative concentration pathway, then climate models actually compute out, well, what does global warming in the future look like with all those greenhouse gases in the atmosphere? So these are emission scenarios, and that's what the climate scientists got together and determined in relation to emissions. So, definitions, sorry, got to apologize. But we need to also think about, well, what other types of scenarios and models are there that build upon the greenhouse gases in our atmospheres. So scenarios actually started in early 1960, and it was in gaming and military planning, believe it or not even anything to do with climate. And it was a systematic way of considering the implications of strategic decisions in the long-term consequences, right? So strategic decisions about, are we going to limit global warming or greenhouse gases, or are we not going to limit greenhouse gases, and what's going to happen in the future? So that's what we're doing when we do climate scenarios. So it's not something that's done only in the climate change science. It happens still in business, in gaming, in all sorts of other sorts of disciplines and applications. But climate scenarios are something that the IPCC has been working on for all of these decades, and now all of the research scholars working in that area. Environmental scenarios are something as well that relate to a particular climate scenario and what's going to happen to the ecological and physical conditions of our Earth system as a result of a certain climate change scenario. So it could be water availability at the basin level, sea level rise, and you'll see these environmental scenarios. Vulnerability scenarios are another type of scenario that look at economics, policy, cultural, institutional changes in relation to climate change and whether certain areas or populations will be vulnerable in the future to climate change. So a lot of social and physical science going in to produce a vulnerability scenario. So we're starting to move from physical science. I wouldn't call it simple by any means, these representative concentration pathways, those emission scenarios, don't get me wrong, but moving from an emission scenario into more and more variables and more integrative models and scenarios in our work. And finally, kind of a catch-all statement, and maybe that's wrong, is integrated assessment models, which are models that are looking at key features of human systems like demography, energy use, technology, the economy, agriculture, forest, land use in relation to climate change. So I have to tell you, I was not part of the writing team in Chapter 1, but there's a box in Chapter 1 of the Land and Climate Report that talks about these scenarios and models, and I could not believe how many times it changed, because academics rarely agree on definitions and brackets and buckets of placing our work. So we have lots and lots of discussions. So this may look simple to you, but my colleagues, my other 106 authors, we probably could spend days arguing about these and whether it accurately reflects climate change models and scenarios. So just saying. But I think it kind of gets across what scenarios and models are and what they might be doing. Okay, so now we had looked at maps that were what has happened to our climate in the last century and a half, right? So now what I'm looking at, and I want to point this out to you, this is Prairie Climate Center out of the University of Winnipeg, and David Sachin, who's given a presentation on climate change, is a member of this institution. And it's an interactive, if you go online, you can find this climate atlas and you can play. It's a lot of fun. I've spent hours, trust me. And you can play and it will give you a whole bunch of projected mean temperatures, a whole bunch of other climate change data that you might be interested in. So I want to point out about three more things on this. First of all, of course, the author who's put this together. It's an incredible feat, incredible work. I was showing it in Portugal, my meeting at the AR6 just a week ago, because they're doing a global atlas. And I was showing them this because I thought it was such great work, and they were actually really impressed. So they're trying to do this on a global scale for the world. So it's great that we have this in Canada. So the representation concentration pathways here, these things. So remember I had from 2.6 to 8.5? So here this is showing you, this is kind of middle of the road in how much GHG is in the atmosphere, okay? But they would show you, if you clicked through, the different RCPs, and it's showing you a baseline here, and then a projected change, and it'll show you a few projected changes. So this is into 2051 to 2080. And then it's showing you the mean temperature increases. So there's a color code, right? So we're looking at 6.1, again, much more expected warming in our Arctic and our north, and reducing down to lower, albeit significant. We're at 2.1 to 3 in BC. Increasing 3.1 here. So if our greenhouse gases are in this range, then we can expect in this time frame to be seeing this type of global projected mean temperature increase. So this is a climate change model, basically. This also is a climate change model, and it's showing you kind of the same information. Remember, we're looking at its RCPs, so how much GHG is in the atmosphere, but starting at 2.6 this time instead of just the 4.5, 2.6 all the way up to 8.5, and then it has the actual anticipated warming in 2100 with these different RCP greenhouse gas pathways over time. Okay. And then we're moving into an integrated assessment model. And I'm going to come back to this particular figure a few times in my presentation. So don't get too worried if you don't understand it or if we don't cover all of it yet. But this is showing us a couple things. Notice that these are emission scenarios to stay below 1.5 degree warming. Okay? So that's the goal. So we're starting to use an integrated assessment model because there's a certain human dimension that's being added in here. And what it is whether we cut carbon emissions starting in 2020, like right now, and do it a steep decline into 2050, or whether it's a less steep decline. And the reason why this is interesting is because it's showing us that delaying a cut for CO2 removal is resulting in a requirement to have more carbon dioxide removal, or negative emission technologies is what we're calling these things. The red is technology for negative emissions into the future. So the more we delay our action, the less steep, the more negative emission technologies that we need, starting here slightly, but starting in this pathway quite drastically, even by 2030. So I'm going to talk about negative emission technologies and CO2 removal later, after I go through a little bit more about climate change scenarios and pathways. Okay? But the purpose of this figure is to talk about the delayed. So that's why it gets into an integrated assessment model, because we're adding that human dimension. So this is from that cross-chapter box I was referring to, where nobody could agree on anything, and that's partly why the language doesn't line up with climate models, emission models, and environmental models. So what we notice from this, though, is we have these socio-economic assumptions around economic development, population growth, et cetera, those factor into the integrated assessment models. They also factor into dedicated land use models that I'm going to show you a bit of later. And there's this interconnection between all of this fantastic work that's happening around crop models, environmental models is what I was calling those, Earth system models, the climate change models, and how the information from one group of scientists is feeding into augmenting and informing the really fascinating work that's happening from other groups of scientists. So it may look like rocket science, but it's kind of understandable when we start to link these emissions pathways together with the climate models and then the human dimensions of some of these models. I'm only going to show you this work by Moss is really, really interesting because it talks about the fact that not only do these models have a relationship or an input together that I was discussing, but there's actually a long history, and these models have evolved over time, and there's two really interesting parts of this history. So first off, in 2006, the IPCC stopped doing a commissioning for these global climate models and scenario developments. So the IPCC used to go to climate modelers and say, please run these scenarios for us. And they would take that information in. And in 2006, it stopped because there was, my opinion, enough of academic work going on in relation to climate change models, assessment models, that the IPCC switched to only be assessing that literature, not having to actually be commissioning it. So moving into the same practice that happens now with all scientific literature, where the IPCC and its authors assess the literature that's available and come to an agreement on how certain that climate change science is. So 2006 was something I think kind of noteworthy that's documented by Moss. And the second change that was kind of interesting is the climate modeling evolved so much so that it became much more integrated. And that coincides kind of with this idea of the integrated human and climate change systems, where instead of looking at a sequential process of climate models that developed an emission scenario and then a climate model and then how would that impact society, that was very, very linear and sequential, to an idea that human societies and human dynamics are impacting those climate models, and we need to be working simultaneously and in parallel together with the human dimensions. So I'm going to speak a little bit on that introduction, which is saying this got really complicated and messy, but it actually got simplified in a bit. So we went from climate models into thinking of these integrated assessments and the human dimensions that impact climate, the human development. What's our economy doing? What's our transportation system doing? And how does that impact greenhouse gases and these Earth systems that we're studying? So that, at the end of the day, is kind of the importance of these things. And what happened is the climate scientists got together and came up with shared socio-economic pathways. So just like the physical scientists had those RCPs, those representative concentration pathways of GHGs that they all agreed on, all right, that we started with. So all of a sudden, the social and physical scientists came up with 5 socio-economic pathways. And this is where the social science starts to really help inform and integrate with the physical science of climate modeling. And the modelers came up with 5 possible future pathways. And they are quite long and boring, so I'm not going to read all of them to you. So I've given you their titles, which you can guess what some of them talk about. So SSP1 is our sustainability. This is the one I showed you that was we immediately reduce our greenhouse gas emissions, back on that figure I said would talk about. So it's SSP1. We take the green road, and there's low challenges to mitigation and adaptation. Middle of the road is really middle between SSP1 and 3. So I'll talk a little bit about regional rivalry in SSP3. So they call it a rocky road. I didn't come up with this, sorry. Here, you can always blame the people I'm referencing at the top. So regional rivalry is a rocky road where there's high challenges to mitigation and adaptation. We have resurgent nationalism, concerns about competitiveness and security, pushing countries to increase focus or domestic or at most regional issues. Policies shift over time to become increasingly oriented toward national and regional security issues. Countries focus on achieving energy and food security goals within their own regions at the expense of broader-based development. Investments in education and technological development decline. Population growth is low in industrialized countries but high in developing. So that's SSP 3. SSP 4 is inequality. And SSP 5, another interesting one, is fossil fuel developments, where the world places increased faith in competitive markets, innovation, participatory society, strong investments in health, education institutions, but there's great faith in geoengineering solutions. So that kind of gives you a flavor of the different narratives that were developed in and about 2015 and published in around 2017 to augment those climate scenarios, to start laying a deeper base work for what might be happening and driving our greenhouse gas emissions into the futures. So, don't fall off your chairs. These narratives are then merged with our RCP's climate forcings that you saw, the 2.6 to 8.5. And yeah, if you're really noticing what happened, they added a couple. So now we have our RCPs, or our climate change RCP GHG forcings, and we overlap with that all of our socioeconomic pathways. And we look at, well, what happens if we're sustainable, or we're on a sustainability pathway, and our GHG emissions are in this range. And the reason these two are gray is because if we're sustainable, we're not going to hit this level of concentration of greenhouse gases in the atmosphere. That's why these are gray at the top. So the climate modelers are starting to link the narrative together with the concentration pathway of greenhouse gases. And here you see in an SSP3, this brown, that it's impossible to achieve 1.5 or well below 2 degrees if we're into that SSP3 narrative. And you remember that was regional rivalry, the one I read you quite a bit of. That's what that means. And here you see the author. It was all in Global Environmental Change, the journal that focused on this. I'm not expecting you to read by any means this table, but this is the table that starts pointing out the delayed action between SSP2, where you're saying delays, and SSP3, where you're seeing late accession, so late movement on greenhouse gases. And that's why I'm pointing out SSP3 again to you, because that is the explanation for the late reduction of greenhouse gases versus SSP1, which is the early and significant reductions of greenhouse gases. And then, for your interest and reading pleasure, these are all of the SSPs, and they're being put on a axis of whether it's a high challenge to mitigation, like a fossil fuel development scenario. So we're going to have to really put a lot of resources into adapting into or mitigating in our future, versus low, which is our sustainability. Our SSP1, we have low efforts in mitigation, lower efforts in adaptation, and then SSP3, remember the delayed action, where we have high challenges to adaptation and high challenges to mitigation. Okay. I know you're all saving your questions for after. Scintillating expose on pathways and scenarios. Okay, so we got through that scenarios and pathways part, kind of the what is it and where have we been and where are we going with this. And what I want to do is talk a little bit about the pathways for the future. So I think I've talked a bit about it, because you can see in the narratives, you can see in the modeling, they're talking about pathways to the future. But how do we use this in an applied sense? How do we use it for decision making, other than, oh, we got to do something, the risk is pretty high right now. So that's exactly what we do. We look at not just the narrative of what that future looks like. And here again, I'm showing you yet again the SSP1, which is sustainability, versus the SSP3. There's some really significant demographic differences in these that are quite determinative of the pathway as well. And those relate to, of course, the GHG forcings that are in each of them, but the population of people in the world, and consumption patterns, right? Some really important things. But when we look at those SSPs 1 versus 3, at constant temperature changes of 1.5, they actually result in different risk levels. So on an SSP3 pathway with more population and higher consumption globally, we actually have more risk in relation to desertification, more strain on our land and degradation, and a higher risk of food insecurity. So we start to be able to use the climate forcings and use the narratives around climate to tease out what that means in the future around risks, barriers to adaptation, barriers to our ability to mitigate into the future. Okay. So with that risk, so how do we bring our GHG emissions down? What's that pathway into the future? And this, notice my social school club mail, I thought it was a great article when they did this. And what it shows you is 2017, the percent of total Canada GHG emissions by sector, and then Saskatchewan, which is great. So it shows us where our greatest source of greenhouse gas emissions are. So we've got agriculture in here, we've got transportation, electricity in Saskatchewan, 10.4 in Canada, 20% in Saskatchewan. So where are the main oil and gas contributors to Saskatchewan's greenhouse gas emissions? And then this is one I promised I would show you again. So I want you to think or internalize with me what this means in a Saskatchewan context. Because what it's showing us is if we do steep emissions to cut to almost zero by 2050, net emissions for CO2 removal, well, that means we're reducing almost to zero our net emissions, and then we're getting into negative emission territory after 2050. And this is all to stay below 1.5 degrees warming. Right? And if we don't, then what happens over here is we need more significant negative emission technologies. And we'll talk about what that is, because I know you're asking. So what does that mean when you think about getting to net zero in 2050? What does that mean when you think about here's what Saskatchewan is emitting now in Canada, if we look at it as a Canadian total problem? So how do we get electricity to zero negative net emissions? How do we get transportation to zero negative emissions, or our oil and gas industry? Here's the challenge to consider. And how do we get this when we have business plans of oil companies that show from 2000 on actual increases in production? There's a significant disconnect happening, and I'm pointing it out to you because I think this is the conversation that we need to start having, and I think it's the conversation that the models actually start opening up for discussion. And who has the biggest carbon footprint? This again came out of that same Globe and Mail article. Sorry, I didn't make it on this one. I must have cut it. Same Globe and Mail article. And I just thought it was a great pictorial for Alberta and Saskatchewan and our GHG emissions per capita by province and emissions intensity by province. Okay. And it gives you some of the facts and figures around, again, the tons of GHG emissions, and how we're going to reduce it. And why is it there? And it tells us Saskatchewan outstrips every other jurisdiction due to its oil and gas production, its potash mining, its coal-fired electricity generation, and its agriculture. It's a significant transformative change that we're needing to tackle climate change into the future. So if we need to get zero, our pathway for the future looks quite daunting. And if we don't start soon, our requirement for negative emission technologies, is what I was calling it, is bigger into the future. So what is that negative emission technologies? Well, it's really about, this was out of The Economist, and I thought it really depicted the carbon shuffle well. Because it's about putting our carbon back into the ground. But it happens through technology. This is direct air capture. There's a couple demonstration plants around the world, but that means basically a plant that's taking the carbon out of the air and putting it in the ground. So picture our Boundary Dam station that's taking it out of the post-combustion coal. So this is actually taking it out of the air. And they're talking about that kind of significant technology. But it's other stuff. It's the CCS that we do provide, which is burning coal, putting it back. That's our carbon capture from a fossil fuel. So it's like net zero. But there's also, this is fossil fuel. This is bad. This is our burning our coal or natural gas into the atmosphere, right? Any kind of fossil fuel. Growing forest is a carbon sink. So our Carrie Finley was talking, she's in the audience, talking about carbon sinks in water, right? So it's more than just the technology that I'm referring to. There's a lot of really good science, and really good agricultural practices for storing carbon in the soil that we want to keep in mind are this carbon sink, this negative or could be a negative emission technology depending on farming practices. And then the other one that's significant in the climate change scenarios is not just carbon capture and storage that we do at Boundary Dam and we do it at the PTRC out by Estevan, but to actually use bioenergy, so to burn our forest wood in our power plants and bioenergy, burn our forest woods and to put it into the CCS storage, right? That's the negative emission technology the scenarios are relying on in the future. Yeah. So that's what we mean. And the Land and Climate Report was looking at those types of processes and whether land could handle the stress that was going to be required of it based on these scenarios into the future. So we're back into, well, what does that look like if we're needing to put more carbon in the ground? And this was my foray into socio-economic pathways. And I'm going to show you this a few times on the next slides, so don't get worried about having to read the fine print. If you're looking for it, it's figure 4 of the Land and Climate Summary for Policymakers. That's where we have it. So the intent was to show through these socio-economic pathways that we have different land use choices that are available to us. And the top line is forestry. So in socio-economic pathway 1, remember this is the really sustainable one to keep it at 1.5. So what we're going to need to do is have more forests. And we're going to need to have more bioenergy. And we're going to have about the same here in natural land. And if we're using more forests and we're using more bioenergy, it means we have less crop land for food and less pasture land for agriculture. So there's decisions and trade-offs is what our socioeconomic pathways are showing us into the future. So this is actually part of, this specific figure is also part of cross-chapter box 7 in chapters 6 and 7 of the Land and Climate. You'll find it there, as well as a big explanation of it. And then what we have over on this side is the SSP5, and this is the intense resource consumption. So what does that look like if we're going to try and keep it at 1.5 degrees Celsius? And it tells you we're going to need a whole bunch of bioenergy, CCS. We're going to need some forest, and we're going to have bigger reductions, is what this is showing, in some of the pasture and cropland. Okay. And then around 3 degrees Celsius, this is the changes that we would have if we only achieve the GHG emissions of 3 degrees Celsius. Okay. So there's these things called shared policy assumptions that are built into these narratives. So a policy assumption is, well, if this is our future, then it means we've got to have programs and practices that are encouraging forestry. There's a policy assumption there. And there's a choice that's being drawn out or teased out of these models. So socioeconomic development and sustainable land management influence the evolution of the land system, including the relative amount of land allocated to cropland, pasture, bioenergy, cropland, forest, natural land, okay? And these integrative assessment models are showing these shared socioeconomic pathways and what they might look like into the future. At the bottom we put indicators. We have these different, from the colored lines, these different quantities into the future. And notice we're always pushing out to 2100 in these integrated assessment models. And we have 2 degrees of warming. We have the 1.5, the 3 degrees, the socioeconomic pathway 1 and 5. So cropland and pasture land decline even in the baseline due to changes in consumption patterns and increased food productivity in these narratives. And this pathway that's 1.5 SSP5 results in large increased sizes of bioenergy, cropland, and area. So there's decisions that happen on the macro level that are policy assumptions, but then there's also decisions that happen on the individual level. So we have, I'm showing this as a kind of a nudge. This is a nudge coming out of IPCC, and the Global Commission on Adaptation has a similar figure that looks at, so how do we influence our surroundings, our community around us, when we think about increasing trees in our urban spaces, community gardens, green rooftops, permeable surfaces for natural infiltration of rainwater, reduce stormwater runoff. Some people call these sponge cities. Ecosystem-based protection. So we need to start thinking about it on our local level. How do we take our energy systems and think about it differently for net zero? We've got energy efficiency appliances, we've got electric vehicles. Not so great if we're using carbon and coal to generate our electricity. Of course, you know solar, wind, distributed generation. And this is coming out of a New Zealand climate change pathway for the future. Whole bunch of little things that we can do around transportation, electricity, agriculture for the future. So, leaving it there, I have, if you want some more information, much of this came from the Climate Change and Land, but what I did do is I used some figures and graphics that I thought told the story in a better way than just me. I'd like to thank the Academics for Climate you met at the beginning for inviting me. And these are all the very important sponsors for this lecture series that we need to acknowledge. And I think this is just going to be really, really great. The next and upcoming lecture is coming up with fake news, political ideology, and climate change, Dr. Gordon Pennycook. So please come back and make sure that you're around for that. So, yeah, I'll open it up for any questions.
I'm good at talking. Could you please explain the term radiative forcing?
Okay, yep, I'll go back to it. Ooh, this way, no, this way. There we go. Okay, so I had a lot of trouble. I was, so I got to kind of explain my journey too. Is I was the CLA for the final chapter on risk decision making and sustainable development, which is my area. But what we had to do was we had to summarize the risks that came out of the first 6 chapters. And in order to do that, I had to dive in deep into your radiative forcing levels. And I hate that word forcing. Like, some climate scientists in the room, tell me why we came up with this term forcing. Like, geez. But anyways, so the radiative forcing values, right? They include the net effect of all anthropogenic GHGs and other forcing agents. So these are the things that are contributing to climate change. And I like to call them greenhouse gas emissions, right? Because to me, that's understandable. So how can I explain it? The way it was explained to me is there's these greenhouse gases like CO2 and methane. Let's take the easy ones. The thing with methane is it's a short-lived gas, but it's very concentrated, and its impacts, and I hate to use that word impact, but the way it perpetuates climate change is more potent than CO2. So CO2 is in the atmosphere longer, but methane's shorter, but it's much more potent to climate change. So when they use this language and they come up with these representative concentration pathways, they're actually calculating out a whole bunch of different gases in the atmosphere. And I bet Britt Hall could give a really good answer to this because it's her specialty, right? So maybe we should turn it over to her. So that's what we're left dealing with. And maybe that's not the great answer, but that's the way I understand the RCPs. It was a way for the climate scientists, and it probably took them months, because I've sat in the rooms with not just physical but social scientists, trust me. And to get physical scientists to come up with an agreement on these 4 that have become 6 RCPs is incredible, I gotta tell you. Yeah, so that's kind of the story behind them. And then they came up with, well, everywhere from 490 parts per million CO2 equivalent, notice that, equivalent, all the way up to 1,370 CO2 equivalent, because it's the forcings of all those chemicals and all those processes. And then, now Britt can correct me.
Well, I'm not going to correct you, but I could give you a little bit more context. So radiative forcing is really describing the nature of how the greenhouse gases in the atmosphere change the energy balance in the transfer of energy from the sun as it comes through the atmosphere and then it hits the Earth. And different gases have different abilities to force those changes to occur. So
that's why they use that word forcing.
I think so, yeah, and I have to say that actually I'm kind of almost making this up because I don't really know, but that's my suspicion.
Thank you, Britt, and thanks for the question. Yes?
I'm curious about your statements regarding comparing or talking about forestry, cropland, and pastures. Now, I know very well that planting a tree, if it's in a proper, if it's in a good ecozone for tree growth, sequesters quite a bit of carbon. In a region like this, however, you're probably much better off planting deep-rooted prairie grasses, which are going to sequester more carbon, and then more to the point, they're going to sequester it underground. So each of these species is going to die eventually, and when they die, the carbon, or these GHGs, are going to be released back in. In the case of grass, they'll be released underground. In the case of tree, they're going to be released into the atmosphere. So why not more consideration for some of the other plant materials that might be useful for sequestering, at least in the sort of 100 to 200 year time frame?
Yeah, actually, that's a fascinating question. Thanks for that. And so this is kind of what I did show you about growing forests, which is simplistic. Because we couldn't plant forests in Regina. And in fact, I don't know if you've been driving to Saskatoon or PA in the past 4 months, but you'll see a lot of dead trees because of the drying that have been killed for whatever reason because of the drought that was experienced along Highway 11, right? So planting trees in an area that where they won't grow isn't useful. So the global models are around afforestation, reforestation, and accounting for growing trees in places where they will grow, like the Amazon where they've been torn down, right? But they're not accounting for or suggesting that we should plant trees in places where they won't grow. Having said that, the urban picture around trees, like that's what our Regina is. And I think it's a trade-off between trees that we have to water and trees that are reducing the heat of a city. So there's a lot of science, and the Land and Climate covered it around urban heat I don't think we call them sinks, but urban heat spots, hotspots, because cities with their cement and black asphalt are really, really hot. So there's trees there that are, I think, really important. But I agree with you. And I got to tell you, there was, I didn't show you this, but I had it in the presentation. Yeah, okay, so here we go. So the Land and Climate Report went through forestation, deforestation, and all of those things, and looked at how they lined up with adaptation and mitigation. But again, we're doing it on a global level. And all of the suggestions around forests, forest management, reduced deforestation, and forest degradation, they're context specific, right? So what we did is, was done in Chapter 6, and Chapter 6, Pete Smith, what he did and his team came up with, well, what are all the response options based on land management that we could have globally, recognizing that each is context specific. And then what do they do to help mitigation? And if it's dark blue, it means they do good things. If it's red, it means, oh, this is, baby, we need to think about this. And if it's lighter blue, then it's less so. And then the high, low, medium has to do with confidence level, those letters that you see there. So I thought it actually goes on for a couple pages. This is just part of it. But it talks about, okay, so what are some of the response options? And agroforestry is one. Well, this doesn't happen in Saskatchewan, but it could. If we've got forests up in the north and we want to start doing agriculture with forests, we could. We just don't think like that in Saskatchewan. But improving cropland management, improving grazing, agricultural diversification, reduced grassland conversion to cropland. That's probably more in line with what you're thinking about, is not taking grassland and putting in forests, but to maintain the grassland where it is with, as you know, in Saskatchewan, we have these deep roots in our natural grasses that retain the carbon in the soil, the moisture in the soil, and are really important to retaining that greenhouse gas sink. So there's this whole host of things. And with the scenarios and pathways that we were modeling, we're looking at it globally and thinking of it globally, but thinking of individual solutions being something that people have to consider locally and whether they apply locally. Fire management, that's a huge thing right now with what's gone on in California and Australia. And what should or shouldn't be done in respect of that. So these were each things that advance mitigation, advance adaptation, and then what are the impacts? Are they reducing desertification? So we have desertification in the southwest part of our province, around the sand dunes, land degradation, and then what is the impact on food security? Yeah. So I didn't really have time to include what's spit out from some of the models, the scenarios, some of the environmental scenarios that were being run. And this is just, again, it's in chapter 6, some of the, and the rest of the page, some of the very, very specific, more context appropriate response options in land and climate.
So are there negative effects of carbon capture and storage underground?
Yeah, thanks for that question. So I can't remember if the Land and Climate Report dealt with that. There are actually several boxes on carbon capture and storage and certainty and uncertainty around storage in ground. So that is in the Land and Climate Report. The summary for policymakers, I don't believe any of the statements made it up to the SPM. Most people just read the summary for policymakers. But there is a huge literature review that was done in 2017 by at least 50 academics on CCS that talk to that aspect. And the Petroleum Technology Research Center in southern Saskatchewan are experts on documenting that the carbon is staying in the ground. Okay, so this report didn't specifically get into that type of aspect, but the IPCC, to my knowledge, about a decade ago, if you Google IPCC, a special report on carbon capture and storage, you'll find one, albeit it's about 10 years old. Okay, sorry, I wasn't involved in that one.
Given the fact that we have water, wind, and solar radiation that can provide electrical power for Saskatchewan, I'm just wondering if anybody has taken any kind of survey considering the total amount of energy used in Saskatchewan and how much it would take or how much we would have to build in terms of solar panels, windmills, and dams for water. And given some of the methods of sequestration that you've mentioned here, it shouldn't take that much to get us below zero net emissions, should it?
Yeah, actually Brett Dolter has written a paper on wind and how many wind turbines would be required in the province of Saskatchewan. and looked at the wind resource. So I know he's been speaking at university events, but he's an expert on wind, and he's done that work. As an economist, and it's really quite fascinating work. So I know of that in relation to wind. In relation to solar, I don't know of a specific Saskatchewan paper or study specifically on solar, but I do know that there are considerations for large industrial scale storage, solar installation, that would be the appropriate word, in Estevan, right, where there's land that's reclaimed from mining coal that might be perfect for it. I don't know. I'm sure there's other areas of the province. If you look at the solar resource for Western Canada, southern Saskatchewan and Saskatchewan has some of the highest solar rating in Canada. So the potential in solar and wind is incredible. But the problem we have is right now, I'm not sure if the wind's blowing out there, but I know the sun's not shining. So we need some batteries, right? So the battery technology is coming, but it's not here yet, right? So that's part of our challenge when we're talking about wind and solar.
I'm pretty sure that it was recently announced that Manitoba will be building an electrical grid east-west to bring hydropower to Saskatchewan.
Yes, we get hydro from Manitoba Hydro, but they're increasing it by 20 megawatts. So it's, and I think it's a upgrade of a current line. It's not a new line that they're having to put through our forests. So it's an upgrade to bring in more. But 20 megawatts, like we're up to about 3,500 or 4,000 megawatts. It's still in the right direction, though.
Margot, quick question here. So what was your pathway to the IPCC? And part two of that, what do you think are the biggest misunderstandings or misconceptions about the IPCC?
Yeah, okay, so I'll start with the easy part. My pathway is I got nominated, right? And I think the stars aligned because it was a special report and my area is drought and flood. And as you can see from the title of the report's on, it's on climate change desertification, land degradation, food security. So my work had been on agricultural producers, how they're adapting to climate change and around water, droughts and floods. So droughts and floods contribute to degradation and desertification. So I think that's how I had hit the sweet spot for being the CLA in the risk and decision-making chapter. And because I had worked with climate modelers, never done their work, got to tell you, still have not done their work, but I have a certain interdisciplinary ability to write papers with climate modelers and scenario people and try and understand main messages and what we need to learn or how we make decisions based on the information that they can tell us. So I got nominated, and then the federal government nominates you, and then the IPCC, as I say, they nominate you again. So you go through the three processes, and then there's a certain amount of experience. So once you've been nominated and you understand how things work, then the IPCC brings in new people all the time, but they also reuse people that understand and have a certain knowledge of having previous reports and having written previous reports to keep a continuity. So that's how I continue into the AR6 and the synthesis of the AR6 materials, which I find fascinating. So I get into this it's a risky area, right, of being a social scientist working on humans and decision making, which is my area, but also having to really understand the climate change models and how we're going to bring together all that science and try and build a product that policymakers can use, right, as a team. So how do we link those response options that I showed you with policies and with decisions? And then, was it the misconception around the IPCC? Yeah. What's fascinating to me is I lived through working in the climate area, criticisms of the IPCC before I was there, and never really knew where to place that. But part of the reason I show what it takes to build an IPCC report and explain the process around building a summary for policymakers and the negotiation of every single line of that summary for policymakers in a room with 210 nations, or 297 nations, arguing about every single sentence. It's incredible to see that process in action. So every single confidence statement that the IPCC makes, and I had them written down, but I wasn't reading from them. So high confidence that droughts and floods and climate change are going to exacerbate food security and are going to increase into the future. So that's some of the language that you'd read in these reports. Well, every single one of those is checked by these nations, like every single reference. When I showed you the burning embers, I lost days of my life developing the burning embers. This was done by a group of about 30 climate modelers and social scientists who reviewed a few hundred journal articles to come up with this figure and to be able to document that in these two different socioeconomic pathways, the risk and the change of risk that occurred from high, medium, low occurs in those areas. They didn't just sit in a room and sing Kumbaya for a couple hours and say, I think this is what this looks like. So, and I'm still, like this last week, the supplementary materials, which are all the references for these figures that came out of my chapter, we finally got those finished. And as academics, if you've ever written a paper and had like 300 references that you have to get right, like, what a task. So we're finally getting to that point. So the amount of work that went into what looked like pretty simple, we call them burning embers diagrams, are intense and crazy. But the reason I'm telling this story is by the time you get through arguing with 30 academics about these transition lines and what these things say and what all the literature says, by the time you get through that process, and by the time you get through a 5-day marathon meeting with nations arguing about what these burning embers should be, you got to know that it's pretty conservative, that nothing really out there, nothing outlandish, nothing really not credible ever gets published in these reports. And some of the background, you'll find this burning embers in chapter 7. You won't find it in the summary for policymakers anymore. So there's some really interesting things that happen that you can track, because this is public information. When you look at what the summary for policymakers is, and then you look in the underlying chapters for what the chapters actually, what they wrote about. And this is one of them that didn't make it. And the other thing that didn't make it, quite frankly, I spent so much time telling you this, because I spent a lot of time on this with a scenario modeler, Kate Calvin from the United States. We spent so much time on these. These didn't make it to the summary for policymakers, right? And the reason is it tells a story that the summary for policymakers didn't, or a few of them, summary for policymakers, a few of the nations didn't think was useful. So we ended up in a breakout room talking about, well, what can or should we say? And part of the thing was, as a group of academics and modelers and nations, what this might say in a summary for policymakers is we're making a choice whether we want to get to 1.5 or 3 degrees Celsius. And we really shouldn't be making a choice to get to 3 degrees Celsius when the United Nations, who we're advising, has, as an organization, committed to well below 2 and 1.5. So why would we ever show a choice or make it look like we have a choice? So this isn't in the summary for policymakers, right? Because we don't want to say that. right? But then why I'm showing it to you is because it shows a decision. It shows trade-offs, which I love the question on grass versus forest. This shows trade-offs, that it's a heuristic, right? It means we're going to have less cropland. People are going to starve. Is that what that means? The price of food's going to go up, right? This is a scenario which I think is great for discussion. Let's talk about it. Because let's move beyond the scenario. But if we have drought and flood and an ENSO event through South America and North America, where we've got failed crops through South America, North America, or failed crops through Europe and Africa, well, what does that do to food prices? And I don't know, because we don't model those and we don't have the science. But we should talk about those types of occurrences. And because we're starting to think about them as academics. We're calling them cascading risks. We're calling them tipping points. And the other tipping point you'll hear a lot about is permafrost degradation, right? When the permafrost gets to a point, and we need a scientist on this, Brit, and it's not me, I just know it's an issue. When the permafrost gets to a certain point of melting, like the glaciers, like the Antarctic and the Arctic, like what's gonna happen? Because it's gonna emit all this CO2, right? And I'm a social scientist, so we don't model that. We don't have the models that I know of, but I'm sure they're working on it. So it's very conservative. So what I knew before the IPCC experience, I wasn't sure. I'd heard allegations that it was not conservative. And since working for the IPCC, I can say it's conservative, but I also know there's peer-reviewed literature of academics writing about the experience and writing about what the IPCC publishes and saying, look, it's really conservative, right?
My research is 2 years old, so I selected January the 1st, 1950 as the midpoint and compared Regina's temperatures before 1950 and after 1950. And what I discovered was that for record highs, we had 174 record highs after 1950, but 192 record highs before 1950. And it appears that we have had, while we have had warmer winters, we've also had cooler summers. And the idea of cooler summers, you know, we've had this 45% increase in carbon dioxide in the last 150 years or so. It seems to be incompatible with the whole entire theory of global warming, because we've got cooler summers now than we've had before 1950. Just wondered if you'd comment on some of that.
Yeah, I don't know your data because, and Elaine Wheaton, I don't know if Dave Sachin, but I know my dear friend from U of Saskatchewan, Elaine Wheaton, is an expert in this area. And we did look at a lot of weather data around, and not City of Regina, but Saskatchewan. And in that climate atlas from the University of Winnipeg that I showed you, they have it documented, not the time frame you're talking about. So there's issues around time frames, right? Because 1950 to now is 70 years. And then do we have records of daily temperatures in the summer from, oh, sorry, I'm a bit jet lagged, but what's that, 1880 to 1950? Because then you'd need the comparison. And I just do know from working in South America and working in Canada, sometimes having that data and the accuracy of that data, my colleague Elaine Wheaton tells me sometimes there's issues. So I don't know what data you're looking at, and whether from 1880 to 1950, what the Regina temperatures were. But if you look at the University of Winnipeg, and I'm sure Dave Sachin, Britt will tell me now, because I've seen him many times, has some of those records around, but not Regina, but definitely the regional and the local temperature changes. But that was, oh, I guess I can show it. Yeah. Oop, Margot, move, move, move. Whoop, whoop. If you look at these, they will actually drill down into the actual temperatures, and they'll actually do it scalarly. So you can hit on Regina, and they'll show you. I don't believe these, I was looking at them recently, I don't believe they go back to 1880. right? Which then makes me question, well, why not? So it is interesting to ask the question, but I do think if you're making a comparison of the number of days, you have to have similar data and you have to have the same time period to make it that. It's really hard with climate change in Saskatchewan because our weather is so variable, right? We have minus 40 out there this morning, maybe worse. And then we get into the plus 30s. So if we just think of climate change in relation to our personal experience in Saskatchewan, when we start talking about increases of 1.9 degrees Celsius in a global mean, right, it doesn't really resonate with us. So we have to go into the Elaine Wheaton, the David Sachin presentations around, the warmer winter, right? And into the West Nile virus and the pine beetle and the other changes that are happening because of these significant changes in less cold winters and what's happening in our summer. Precipitation is a bit difficult, as Elaine would mention. But river flow is something that they can get a little bit more accurately in their data and in their forecasts.
So what I love and so much appreciate is that you are giving a face to the IPCC for us. Usually we hear about it through the media and it seems so far away. So I recommend that everybody, if you're interested, take a bit of time and look at the website, because not only is it very informative, but there's lots of videos of
I did one of those. Hi, I'm with the IPCC.
Yeah, it's just like people from different parts of the world who are representing science from places more remote than Regina. It really puts a face on the IPCC. I have a couple of questions forming for you. I wonder about how this information gets to policymakers.
Oh, great.
Well, we sort of know what their response is, but can you talk a little bit about that?
Yeah, so the summary for policymakers is really written for a policymaker, and a public audience. So it's meant for a person that's not really steeped in the science, not really knowing the science. So we try and use accessible, I hate to use the word plain, but plain accessible language. And that's how it's written. And then with every nation in the United Nations, it's the people from Canada are the Environment Canada, the Natural Resources Canada. Those are the bureaucrats. Those are the bureaucrats that do policy and advise our federal Minister of Environment, right, and Natural Resources about climate change. And they're really, really experts, right? Some of them occasionally have PhDs in climate change or in a similar type discipline of biology or something. And I was really, really impressed with our federal bureaucrats and their level of knowledge, because they're tasked with going to all of these meetings. We as scientists sat through the 5 grueling days and nights, and they do it regularly when the plenary of the IPCC. So it's not Justin Trudeau. They made the Trump or Trudeau's or Obama's may show up at the United Nations framework negotiations, which are different. They're not the IPCC. But at the IPCC, it is the policymakers, or some of them. Then there's an incredible outreach effort that the IPCC makes so we've stayed up for 2 days solid, and we start doing media interviews when the report's finalized. And all the scientists are doing media interviews for public, but also to try and get the summary messages out. The IPCC gives us these slides, not all of them, I attribute them, but like this is an IPCC slide. They give us every single figure. This they made up, I changed it a little bit. They give us all the graphics and all the figures for us to go and give the presentations after the report is made. So there is a colossal effort. I found it a little frustrating coming from Canada when we were told, as we were drafting a summary for policymakers, that certain language would be beyond a policymaker's understanding. Because I knew in Canada or the United States that just wasn't true. So they always had us writing at a level I thought was lower, right, sometimes, than I was comfortable with. But then there's a technical summary. So if you're a real climate change geek and you like hard reads, because you might not know all this language, look for the technical summary, because the technical summary is the compilation of all the executive summaries of the chapters. And it is actually the document that we put together for the policymakers that are deep experts. It's the executive summaries, which are, we call it the technical summary, which is the compilation of every single chapter's executive summary. And it's a beautiful thing. Sorry, I don't have it here, but it'll tell you which chapter and which paragraph you will find the information if you want to know more about it. So it really is not just an executive summary, but it's a map to the entire report. A lot of efforts put into that. I hope more or enough. There was also a call out for materials to be prepared for grade and high school. So I missed it, but in January, volunteers were getting together of the science teams, the scientists that wrote these, to try and make materials accessible for teachers in their classrooms. I thought that was a great effort, and that's ongoing. Yeah.
So Margot, looking at the picture you have up on the screen makes me start to think about agricultural practices, how it varies, from province to province in Saskatchewan compared to Ontario, and the sequestering of carbon. So when you're looking at those, is it an world average for this, or is it region specific in the methods for agricultural practices?
Yeah, great question, David. Thanks for that question. So there's actually two answers. So, where is it? So that task force on national greenhouse gas inventories, we had a few people working on the land and climate that worked a lot on that task force. And these scientists are so knowledgeable about absolutely every practice and policy from, I call it cradle to grave, like the forest information. Like if you grow a tree, it sequesters carbon. And if you, never thought of it this way, if you make a wooden table and chairs, well, that stores carbon forever until you get rid of that table and chairs. Wood products, right? So there's scientists that actually know in this greenhouse gas inventories and the work that goes into those type of things about this information. And they know about our soils and the storing of carbon and our farming practices. And the thing I paid particular attention to, just because I'm from Saskatchewan, is the argument around min-till and whether it actually sequesters carbon. Because here in Saskatchewan, we believe that min-till, and I hope everybody knows what I'm talking about because I'm not sure David will have to explain it too because he is an agricultural producer. Min-till, like less working and cultivating of the land, right? Like we only pass it once with our equipment. We don't do it like we used to do it with 2 or 3 passes, right? David will correct me after I'm wrong. Anyway, so we feel that that sequesters more carbon. Okay, so Pete Smith's chapter, which was 6, not my chapter, but I had to read every single chapter to try and do the policies. And there's not the peer-reviewed literature to substantiate that min-till sequesters carbon. So we may feel it does, we may think it does, but we don't have the peer-reviewed literature. We don't have that level of proof and evidence that would allow that response option chart I showed you to have that this practice of agriculture is storing the carbon, right? So, what I had? So I had other things about soil protection, et cetera, et cetera. We know that. So there's more work to be done around agricultural practices and what stores carbon and what's helping climate change. And my opinion is that we would be really well served as a province to be able to measure and account for our agricultural practices and stand up as a global leader to say that our food that we're producing is some of the most efficient in the world and the most less intensive in greenhouse gas emissions than other areas of the world. But we need the science and we need the accounting and inventory to do that. So the answer is it has to be in the literature to be able to stand up and document that actually does store carbon. So it has to have specific studies. And I was sitting in a meeting with the Minister of Environment in December and some of the U of S people that do this work. And we had this conversation that, you know, we need to document and be able to prove that this agricultural practice is storing carbon. So we need to do it locally. And then once the IPCC gets all these local studies, what we do is we say we've assessed the literature and we're medium confident if we have 5 studies that say Mintil or this practice stores carbon and is reducing greenhouse gas emissions. That's when we can do it. So it's kind of a local thing that then becomes a statement. But then it's always context specific. And if you're in chapter 6, they actually got into specific crops that stored carbon versus other types of crops, specific trees and shrubs that stored more carbon than other types. If you read the chapter, I'm sorry, I can't remember the names of them. So it gets very specific, but generally not, in an assessment like this, regional. So I don't know if that helps. You need the specific evidence, and then you kind of make a kind of a statement that's depending on the context.
Could you provide an example of a policy for adaptation in flood and drought that's happening in this province?
A policy for adaptation of drought and flood. Oh, I love difficult questions this late at night. Okay, so what we did, I don't know if I kept this, I think I did. Oh, here we go. So what we did was chapter 6 did all those beautiful response options, and not to be outdone, we took all of their response options and we put in, okay, what are the policies that actually advance these response options? And then I worked on, I'm working on the desertification cross-chapter paper, the drought and cross-chapter paper with the AR6 working group 2 team. So the same things are coming up. And so what policies respond to drought and flood? And they're in this table, actually. So one could look at them, and they're in this cross-chapter box. So beneficial farm practices, the environmental farm planning that's been happening, in my opinion, it's about looking after our soil. And drought and flood, we know, are corrosive and bad for our soil. So I know it's not directly addressing drought and flood, but it indirectly is. So when we put together a table like this, we were looking at all of the policies that help. Crop insurance, in a way, helps because it keeps agricultural producers able to continue to be stewards of the land, right? So in a way, it's a adaptive policy in relation to drought and flood. So we put together those for the specific reason that you're looking, but we took a very broad view of what addresses drought and flood. Because often policies don't say, well, it's specific only to drought. It's to kind of a broad range, if that helps.
Thanks, Margot. Okay, so you are sitting in the fire in a way, you know, you're looking across all of these forecasts. Even the best one isn't so great. And the IPCC, as you say, is conservative. So, wondering how that feels for you as a human on the planet. And also, have some quiet time and meditate. Exactly. Also, too, like last week, Antarctica had its highest temperature in history, 18.3 degrees, as you probably know. And how does that fit in with these forecasts? Is that a surprise? Is that, I mean, yeah, so I'll let you respond now.
It reminds me this morning I was on CBC, and when I started talking about the songbirds being extinct, they cut me off, right? So sometimes I feel like that, like you're being cut off and not listened to. And it's funny because around the IPCC, we, Mark Hammond from Australia wrote it was Andy Reisinger from New Zealand wrote a haiku, and it was kind of like, "Are you listening?" was the beginning of it. And it's posted online, but it really kind of, and he's a member of the TSU, so he's kind of affiliated, let's say, more closely than I am. And he's been working on it a lot longer. So I think there is a certain amount of frustration, right, with having written the message and not having had the problem addressed. But then there's a certain amount of optimism that it comes from the Academics for Climate Change, for keeping the discussion alive, right, through, and not letting the reports, the 1.5, the land and climate, the cryosphere reports, not letting the information and the scientists, they're working so hard on the pieces, not letting it fall into oblivion and only be read in a journal article that the IPCC addresses 5 years from now, is the time lag, right? So I think these things make us really optimistic. And of course, the youth, the Saskatchewan youth, the international youth, I think, picked up our spirits. So Greta was at Geneva when we were negotiating this, and she and 5 others came and they gave a presentation to the IPCC and the scientists, and it was towards the end, so because I was chapter 7, I was in at the end, so I couldn't go, but one of my authors did, and she said that Greta wasn't, but a couple of I think it was a young man and young woman, were just crying, like when they were making the presentation to the scientists, and so thankful for the scientists, et cetera, et cetera. So it was really moving for the young woman that was on my team who works at the United Nations to have that kind of interaction. So there's things that really do pick up the scientists and the people that are doing all this work, and I'm sure the scientists in this room that are advancing, having their science and having this important issue advanced by this series. So I applaud the organizers, and I think this is just great. And all the people that have come out and have continuously come out to hear and to learn and exchange ideas. Because I think pointing out the dysfunction between what we need to do and what we're doing, I think that's important.
Thank you so much, Margot. It was amazing to hear you, all your sharing. And maybe you can tell your academic friends about Academics for Climate so they can start it at their universities.
Hey, that would be great. Let's work on a couple PowerPoint slides and we'll send it around. The film, the map creative person.
So please join me